on a horizontal plane, we take the direction that is plus y direction to be the north direction, minus y direction to be the southward direction, plus x direction to be the eastward direction, and minus x direction to be the westward direction. And they have already said the origin coincides with the foot of the mango tree from which the search begins. So taking this mango tree's base at the origin, whose coordinates are 0, 0, let us see how the hunter has to move. He is walking 8 meters at 30 degrees south of east first. So this is the motion. In the first part, as you can see, this I am calling to be a displacement vector, that is OA. The length of this vector is 8 meters and south of is 30 degree. Well, I have already taken plus x axis direction east and minus y direction is to be south. So when I say 30 degrees south of east, it means the angle has to be measured clockwise in my figure from the plus x direction, that is towards the minus y axis, and this angle is 30 degree. That is the first part of the motion. After that, this treasure hunter has to turn to his left to 60 degree. Like if he is walking in the direction OA and he turns to his left 60 degree, then obviously you have to measure the angle from this white dashed line in the anti-clockwise sense through 60 degree. And the second part of motion I am representing by this displacement vector AB here. And the length AB, that is given to be 5 meters. So these are the two motions of the treasure trove hunter on the ground level, ground surface level, okay, in the horizontal plane, and that's why I could describe those motions with two displacement arrows, both of which are lying in the XY plane. So first of all, let me find out the location of this point B at the end of these two-part motions. So as a first step, what we can do is that we can consider these two displacements, OA and AB, separately and resolve them into their x and y components. The direction of OA shows that it has got a plus x component and a minus y component. Accordingly, I show separately a coordinate system with a plus x axis and minus y axis and draw this vector OA separately again. So this is the displacement OA. And this angle is 30 degree. They have said this is 8 meters. Resolving the displacement in its two components as shown in my figure, as you can see, if this angle is 30 degree, we have got a plus x component of magnitude 8 into cos 30 meter. And you have got a minus y component of OA, that is 8 into sine 30 degree meter. Therefore, we might express the displacement OA vectorially as 8 cos 30 degree, that is the magnitude of x component. In the plus x direction, unit vector is I cap, plus go for the y component, magnitude is 8 into sine 30 degree, and in the minus y direction, unit vector is minus j cap, therefore multiplied by minus j cap, and this whole thing must be expressed in meters. You can make a calculation, cos 30 is root 3 by 2, sine 30 is half, show that. So OA vector is coming out to be 6.93 into I cap minus 4.00 j cap meters. This is the vector OA. Similarly, we can once again resolve the next displacement, that is AB now. And as you can see, direction of AB is such that it has got a plus x component and a plus y component. Therefore, I draw a separate coordinate system with a plus x axis and plus y axis, and let me place this displacement AB so that its tail coincides with the origin. Look once again at the figure. This angle was 30 degree. Therefore, this angle is also 30 degree. And if the hunter has rotated through 60 degree anticlockwise sense, it means that this direction AB is making an angle of 30 degree with the plus x axis. I am trying to tell you here, this angle is 30 degree. Let's see once again. He is moving to an angle of 60 degree from this direction, which itself is making an angle of 30 degree below the plus x axis, and therefore direction of AB makes an angle of 30 degree with the plus x direction in the anti-clockwise sense. So this is 30 degree. The length AB they have already set to be 5 meters. The resolution of this displacement again, and we have got an x component of magnitude 5 cos 30 degree meter, and then y component of magnitude 5 into sine 30 degree in meters, right? So let me write this. I'm calling it to be AB vector, of course. This is AB, and the AB displacement is coming out to be the x component, that is 5 cos 30 degree. The magnitude in the plus x direction in vector is I cap, plus y component magnitude is 5 sine 30 degree, and in the positive y direction unit vector is plus j cap only, isn't it? And this whole thing unit is meter. Once again, you can check that the first part is coming out to be 4.33 I cap plus 2.50 j cap meter. So we have got here the displacement parts OA and AB expressed in terms of I and J as shown. And as the hunter has traveled on the ground level to these two displacements OA and AB by triangle law, the net displacement of the treasure trove hunter on the ground can be expressed by this closing side in reverse order, that is the side OB here, isn't it? So the displacement of the hunter on the ground given by OB, which is OA plus AB by the triangle of vector addition, and since you have got both OA and AB expressed in terms of I and J, simply go for adding 6.93 plus 4.33, rounding off to 3 significant figures. This is coming out to be 11.3i. Just check it. Similarly, minus 4.00j plus 2.50j. This is coming out to be minus 1.50 j cap.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.